When you first become a junior developer, your code will look like Play-Doh snakes, but as you progress to senior developer and learn about software design patterns, your code will look like the Sistine Chapel. But when you then progress to principal engineer, you'll realize that nobody wants to maintain the Sistine Chapel for a silly website and go back to making Play-Doh snakes. In today's video, you'll learn about 10 different software design patterns, along with the pros and cons of using them, which can be very subjective and controversial. One of the most influential books in the history of programming is Design Patterns by 4 C++ engineers called the Gang of 4. It breaks down 23 different approaches to address recurring problems that programmers face, which are categorized as creational patterns, how objects are created, structural patterns, how objects relate to each other, and behavioral patterns, how objects communicate with each other. Becoming a proficient software engineer is not about memorizing the syntax of a programming language, but rather the ability to solve problems with it. By the end of this video, you'll understand a variety of different patterns for solving problems as they relate to modern app developers. Before we get started, I want to give a big shout out to refactoring.guru. They gave me permission to use some of their graphics that explain design patterns better than anything else out there. They're based in Ukraine, and it's seriously one of the coolest programming websites on the internet. Design patterns are really interesting because they're not just like algorithms that you can copy and paste from Stack Overflow. You actually need to use your brain to implement them. It can be tempting to implement them all over the place, but when used improperly, they can add additional complexity and boilerplate to a code base. The book is not the Bible, and there are many criticisms of it. Regardless, knowing how to recognize design patterns will help you level up as a programmer. The first pattern we'll look at is singleton, which is very easy to understand. It's a type of object that can only be instantiated once. In TypeScript, we might implement a singleton class called settings to represent the global app settings data. We'll give it a static instance property and then make its constructor private so that it cannot be instantiated with a new keyword. We then create a static getInstance method that will check to see if the instance has already been created, and if not, it will create a new one. And that ensures that only one object can be created. That's great and all, but here's where things become a little more nuanced. In JavaScript, we have object literals and also the concept of global data, and objects are passed around by reference. We get all the same basic characteristics as this pattern by simply creating a global object. The pattern itself is really just extra boilerplate that we don't need. It's an entirely different story in C++, but the moral is to lean on your language's built-in features before implementing a fancy design pattern. Now let's take a look at the prototype pattern, which is just a fancy word for clone. If you've done object-oriented programming, you should be familiar with inheritance, where a class can be extended with a subclass. One problem with inheritance is that it can lead to a complex hierarchy of code. The prototype pattern is an alternative way to implement inheritance, but instead of inheriting functionality from a class, it comes from an object that's already been created. This creates a flat prototype chain that makes it much easier to share functionality between objects, especially in a dynamic language like JavaScript, which supports prototypal inheritance out of the box. Imagine we have an object named zombie. This is our prototype, but now we want to create a new object based on it that also has a name. We can do that with object create by passing the zombie as the prototype, then specify additional properties like name for the new object. The interesting thing is that if you log this object, you'll only see the name and not the eatbrains method. However, if you try to call that method, it will still work. That's because JavaScript will go up the prototype chain until it reaches the root, looking for any methods or properties on the parent objects. You can always get the prototype from an object by using this proto property. However, that's not a modern best practice, and instead you should use object get prototype of. Now, when it comes to classes in JavaScript, prototype refers to its constructor, and that means that we can extend a class with additional functions if we want to. However, that's also generally considered a bad practice. Now let's switch gears to the builder pattern. Imagine you're running a hot dog stand, and when a customer places an order, they need to tell you everything they want in the sandwich in the constructor. That works, but it's kind of hard to keep track of all these options, and we might want to defer each step to a later point. With the builder pattern, we create the object step by step using methods rather than the constructor, and we could even delegate the building logic to an entirely different class. In JavaScript, we'll have each method return this, which is a reference to the object instance. That allows us to implement method chaining, where we instantiate an object, then chain methods to it, but always get the object as the return value. You'll come across this pattern frequently with libraries like jQuery, but it's gone a bit out of style in recent years. Another pattern you may come across is factory. Instead of using the new keyword to instantiate an object, you use a function or method to do it for you. That may sound trivial, but here's a practical example. Let's imagine we're building a cross-platform app that runs on both iOS and Android. They both have the same interface, but in our code, we're doing a bunch of conditional checking to determine which button to show. That's not very maintainable. Instead, we can create a subclass or function that will determine which object to instantiate. Now, instead of repeating the same logic, we use the factory to determine which button should be rendered.
We are going to tackle today the abstract factory pattern. Therefore, if you haven't watched our previous upload or have no idea what the factory method pattern is, I suggest you take a look at the video link down below in the description first. So, the abstract factory is a creational design pattern that lets you produce families of related objects without specifying their concrete classes. You can think of it as if you were using the factory method pattern but multiple times, or as if you were scaling up your factory to handle the creation of multiple distinct products. Okay, as usual, and to better understand the concept at hand, let's take a practical approach and imagine you want to simulate the creation of computer parts. Now, to not overcomplicate the example right from the beginning, suppose we are just manufacturing GPUs. Now, the GPUs we are manufacturing belong to a certain brand, and the brands covered by our company are MSI and ASUS. If you've watched our factory method pattern video, you may have already noticed the analogy of this example with the restaurant one we gave back then. So let's go ahead and try to apply the factory method pattern on this example, all while trying to relate it to our current example. The company class here is the abstract factory itself, and this factory is implemented by concrete factories, which are the manufacturer classes in this example. Each concrete factory is responsible for creating both products, which means that both factories should and must return the same abstract product or interface. However, the concrete product created should correspond or relate to the type of factory it was created from. So to recap, you should use the abstract factory pattern when your code needs to work with various families of related products, but you don't want it to depend on the concrete classes of those products, though they might be known beforehand, and that's why many designs start by using the factory method pattern as it is less complicated and more customizable via subclasses, and later evolve toward an abstract factory design. By using this pattern, you will be following and applying the open-closed principle and the single responsibility principle as you are centralizing the product creation code in one place in the program. So, that's it for this video. I hope it was helpful. Thank you guys for watching, take care, and I will see you on the next one.